So today, good morning to all, good afternoon, ladies and gentlemen. Today, what we're going to start is we're going to start radiative forcing or radiative balance. So actually, what does it mean? It means that whatever energy from the sun or whatever energy from the sun we are receiving from the sun ends, how that energy is going to be have a good effect in the earth system, right? Now whatever energy we are receiving from the sun, that is being absorbed, and then definitely that is being radiated out. So in order to get the actual balance, you need to understand first the radiative forcing, and then how much energy that is being received from the sun, that we need to understand. And next to that, we will going to have one question related to greenhouse gas, and then we're going to end the session. That's all for the introductory part. Now we'll going to the detail one. So in the first slide, but as you are seeing, myself Chiranjeev Banerjee from Gurukul Kangadi University will going to deliver the lecture on radiative balance or radiative forcing. Now, so energy that is being received, that is being emitted by the sun, is actually the surface area into the flux. So Ts and Te, we have two different terms. Ts is for temperature of sun and Te for temperature of the earth. So energy that is being emitted by the sun is actually 4 pi r square. That Rs denote for sun radius. Ts means temperature of the sun. So what we're going to have is, we'll emitted the temperature is actually 4 pi r square sigma to the power 4, right? Next, what we're going to, this temperature that is emitted by the sun is going to distributed uniformly in the figure you were just seeing, that over the disk into the earth is your Fs. So is uniformly at the distance, at the diameter d, at the radius, it is actually radius d, we're going to have Fs Es by 4 pi d square. Now this Es is nothing by, again, that is written, so 4 cancel out, pi cancel out, so we got that sigma to the power 4 Rs square divided by d square. So this is actually what we have that as a solar flux. It is also defined as Fs. Now when we're going to put all the numeric values, right? So sigma is temperature of the sun, right? Then we had radius of the sun, and this d is going to, for any planet, this d will vary, right? For any planet, as the distance from the sun for each of the planet varies, so every planet will have a different d. Now what we'll have is, if you solve for this, you will get Fs as 1370 watt per meter square. If you go for this one, if you go for so what we'll have Es by 4 pi d square, right? Now if you solve for this one, you will get the value of Fs as 1370 watt per meter square. Now this Fs is intercepted by the earth over a disk of a cross sectional area of pi r square, represented by the shadow area, means this black one, right? This black area. And another we need to understand, that is a concept of albedo, that is nothing but the reflective index. Actually, whatever the radiation that is being received by the earth's sun ends is not going to absorb completely, right? It is being reflected back to the space by the ice, which is referred, or which is defined as albedo. So this is this albedo, the value of albedo will going to have different values, will going to have differ from planet to planet. The value of albedo is not constant, though the other value are constant. So definitely depending upon this albedo, your T will change, understand. So what we'll have is the solar radiation absorbed per unit time is given by pi r square into 1 minus albedo, that is represented by this equation. And at the end, what we're going to have, if we're going to mean solar radiation per unit hour, you will going to have the equation number 1. So this equation number 1, what it represents that sigma t to the power 4 equal to fs1 minus a by 4. This not a, sorry, alpha. That's alpha and a are same. That represent the albedo. Now, if you're going to solve this one with respect to the value as an albedo of 0.28 for Earth, right? Fs is 1370 watt per meter square. Sigma is 5.67 into 10 to the power minus 8 watt per meter square to the power 4. If you're going to solve for this one, we'll get the value of T as 255 Kelvin, right? 255 Kelvin. So can you imagine the temperature of the earth is 255 Kelvin, which is around minus 18 degrees C. Are you feeling so? Definitely not, right? So now the questions comes that if after solving that is also known as effective temperature of the earth. After solving this one, we'll get T as 255 Kelvin. Now, who is the culprit actually? Definitely it's too hot. So definitely the culprit, whenever it comes in terms of the atmospheric science, the answer goes into the favor of greenhouse gas. So this greenhouse gas is a culprit actually. So we need to add delta E in order to get the actual radiative forcing by putting the actual temperature as 288 Kelvin. Now if you're going to solve this one by putting T as 288 Kelvin and sigma, Fs, albedo are constant, you will get the value of delta E as 149.98 watt per meter square, approximately 150 watt per meter square. So delta E is 150 watt per meter square. This radiative forcing is being contributed to the earth by the greenhouse gas. Okay, this is the actual contribution by the greenhouse gas, right? So if you're going to solve a question, suppose the question is this one, what would be the earth atmospheric temperature if the greenhouse gas increased by 10%? So this question was taken from Heights, Ronald's Heights, that is an atmospheric chemistry. It's a very good book. We had another book that is known as R-Stall, right? R-Stall. So I've given the reference in the first slide itself. So here, if you see, what would be the temperature of the earth or the atmospheric temperature एटमॉस्फेरिक टेम्परेचर क्या होगा अगर हमारा ग्रीन हाउस गैस का कंसंट्रेशन जो है वो 10% इंक्रीज हो जाए. तो आई टोल्ड यू एज इन द प्रीवियस स्लाइड इटसेल्फ कि डेल्टा ई इज़ द एक्चुअल टर्म फॉर द ग्रीन हाउस गैस. ये 150 वाट पर मीटर स्क्वायर ऑलरेडी सॉल्व करके हमने पिछला स्लाइड में कहा. तो 150 वाट पर मीटर स्क्वायर इज़ द ग्रीन हाउस गैस. तो अगर उससे 10% बढ़ गया तो हम सीधा का सीधा 150 के साथ 10% जोड़ देंगे. तो 150 का 10% होता है 15, तो 150 प्लस 15 है 165. 165 वाट पर मीटर स्क्वायर इज अ न्यू रेडिएटिव फोर्सिंग आफ्टर इंक्रीजिंग द ग्रीन हाउस गैस. सो इन ऑर्डर टू फाइंड द न्यू टी, दैट इज न्यू टेम्परेचर ऑफ द एटमॉस्फेरिक टेम्परेचर, नया क्या कितना टेम्परेचर बढ़ेगा, डेफिनेटली टेम्परेचर तो बढ़ेगा, राइट. सो इट्स अ हिंट दैट all the value are constant, go for T, put sigma Fs albedo and delta E as 165 watt per meter square, not 150 watt per meter square. If you put delta E as 150 per meter square, you will get the value of T as 288 Kelvin. But definitely the question was being asked with respect to the greenhouse gas. So definitely if the greenhouse gas increases, your radiative forcing or delta E will also increase. Okay. So thank you.